So far we have discussed only abstract vectors. However, the reason for introducing vectors is that many physics quantities are conveniently described by vectors. Among them, velocity, force, momentum, and gravitational electric field. So if you have this force, velocity, as I have already described you, that gravity, electric force, magnetic field, they are a vector quantity. So you have to understand the operation, how we can do it. Now in this chapter or in this section, we are going to learn following thing. In this chapter, we shall use vectors to discuss kinematics, which is description of motion without regard for the cause of motion. So in this chapter, what we are going to, first chapter is, we are going to talk about kinematics using vector, but we don't understand here now that what causes some objects to move. We will only just understand that okay, something is moving in some space, okay, in Cartesian coordinate system, like in three-dimensional space. We won't understand now for the moment that what causes this motion to happen, but we want to understand that okay, if somebody moving like this, then how do we understand the kinematic or dynamics of this moving object? So kinematics is largely geometric and perfectly suited to characterization by vectors. As I have told you that kinematics is a very geometric thing because everything is moving in this particular system. So for an example, what do you mean by position vector? Position vector means if you pick any coordinate system here, x, y and z, and if you want to specify that where is the particular coordinate like x1, y1, z1, okay, so what we're going to do, take from origin and we describe a vector here. We say that the object is some specific coordinate like x1, y1, z1. Like in Earth, you have this GPS system, and in Earth we have this north and south. So somebody said that I am here. So in north system, like we are 23° north and 48° south. So if you have this coordinate system, you can move to any location in Earth. Similarly, in physics language, we are saying that if you want to really understand some object location, we have to first identify where it is. The identification happens because of this position vector. We are calling it R vector. So as we know, first of all, we translate everything in this scenario that x1 x hat, y1 y hat and z1 z hat. This is the simple meaning of this position vector in three-dimensional space. Now somebody will ask you that okay, if I am having this 2 points, like one is x1, y1, so okay, let me just not write too many things like z. If you understand this two-dimensional thing, you can easily simply just move to three dimension, no problem. So if here we have two locations, like we are in coordinate system xy, one is x1 y1 and another object is in R2. Now we have two objects and they are located at 2 points, x1 y1 and x2 y2. Now somebody will tell you what is the distance between these 2 points like A and B. I have the following object like A and B and their coordinate is fixed. Now we want to understand what is the displacement or what is the length between these 2 points. Means they are asking me, or we are calling it S vector, the displacement. So let me just displacement denoted by R vector. Do not confuse with R1 and R2. R1 and R2, they are just coordinate system. So I have yesterday discussed about triangle law, where we are saying that we start from somewhere, we follow the continuity, like we are going from this one to this one. This is same as going from this to this. So we say that R1, I don't know what is your R vector. So what we are going to do? Hang on a second. We have to follow what is your R vector. To follow this R vector, we are going to write here R1 vector plus this continuity. R vector is nothing but your R2 vector. Okay, so my R vector is going to nothing but R2 minus R1 in 3D or in 2D. So R2 consists of x2 x hat, y2 y hat. minus x1 x hat plus y1 y hat. Now I have already told you the addition and subtraction can happen only with the same axes, same direction. Therefore I can write here x2 minus x1 x hat plus y2 minus y1 y hat. Or in another form we can write here simply r vector is nothing but x2 minus x1 comma y2 minus y1. This is similar as we have written here. Okay, so this is actually giving you the coordinates. So this is the displacement. So to understand the displacement it's nothing, it's not telling you about anything that what happens to some points. It is saying you that to understand the displacement of any 2 points, you have to understand what is the endpoints of it. So if you know the endpoints of two endpoints of any vector, you can simply find out what is the displacement, what is the length of that vector. So you can find the magnitude of that length. It's nothing but x2 minus x1 square, y2 minus y1 square. Now if you want to find what is the angle of this thing, y2 minus y1 and x2 minus x1, and we call it in mathematical language slope. What is the slope of this vector? And the theta is making with x-axis. So this is the very interesting result you can easily find using the vector thing. So displacement we can define. If we have this position vector, we can simply describe what is the displacement. And now to understand this r vector, that is too much important, because when you actually writing some equation, you have to first specify which object is there and from which point we want to find this electric field, magnetic field or gravitational field anywhere. So this is, for that sense, it is very much important. Now what we are going to understand here, that velocity. What is velocity? Maybe this video is going to again too long, but excuse me for that. So we want to understand velocity. Velocity, as we understand it, the change in distance over the change in time. So any object is moving like this. Okay, so some object, the point from origin, like this is your x and y. So at some time like t1, it has some position r1, and at some time it has position like r2. So the velocity is nothing but change in this position. Let me just coordinate it, like r1 is nothing but x1 y1, r2 is nothing but x2 y2. Okay, the change is simply drawn like this, and we are actually drawing a perpendicular from here to here. Okay, so it is nothing but perpendicular goes to this point right here, and we call it delta r. So delta r, like here, like delta r over delta t. Delta r means that it's saying that x2 minus x1 comma y2 minus y1 over t2 minus t1, which is in 2 dimensional basically. Or in 1 dimensional, you can write here in 1 dimensional, in 1D, one can write simply. Now since we are working with vectors, so vectors in 1 dimensional, like only v, is simply x2 minus x1 over t2 minus t1. So this is actually giving you the average velocity. Okay, now average velocity, since we are writing v in 2D, like vx x hat plus vy y hat, therefore this result actually translate in component wise here, like v vector is x2 minus x1 by t2 minus t1 x hat plus y2 minus y1 over t2 minus t1 y hat. So this is the form of velocity in 2 dimension and 3 dimension, and you can simply translate back in 3 dimensional in the following way. Now we have to understand that how can we introduce calculus in this, because we have what we have defined here The definition is simply of average velocity. What is the average velocity? This one and this one in one dimensional and two dimensional, we have defined this average velocity. But to understand the calculus, we have to introduce what we call derivative. So we simply follow the same pattern here. Like any object is moving, R1 and R2, T1 and T2. But what we're gonna say that now this T1 and T2, they are not too much great. Now T2 is nothing but T1 plus delta T, where delta T is very smaller than 1. Okay, as if I am choosing that delta T if goes to 0, means that T2 and T1 becomes same point. Okay, so we are just like here. So the interesting thing is here, if I am having this velocity like in two dimensional also, I am going to introduce like here R2 minus R1 over T2 minus T1. But the interesting thing is here R2 is nothing but R1, or maybe some point like R1 T plus delta T. Okay, because this position, this R is same as this one, because it is not has gone too far, and again simply R1 over, now T2 I have already defined it here, T1 plus delta T minus delta T, sorry, minus T1, hang on a second. Okay, so T1 plus delta T minus T1. So R2 I have written here that R2 is some sense that this is the R1 actually. The thing is that this is the R1, the same object is actually travel very few distance. It is same as that delta T is so small that you just simply goes to, if it is goes to 0, T2 and T1 will be overlapped, and if it is not 0, then it is very smaller than 1. So as if we have to introduce that del T goes to 0. So let me again write this thing, that we are actually defining that limit delta T goes to 0, R1 T plus delta T minus R1 over delta T. This is the velocity description. So I can write here dr vector over dt. Now this is the, by the way, this is the definition of also the differentiation, that if you have any function like x plus delta x, some displacement, some curve is actually taking, maybe this is a curve of function f of x. Okay, now it is x, maybe it is your x, and if it is coming here like x plus dx. So what is the value of function at x, and what is the value of function like x plus dx? So we change this from 2 points like f of x plus delta x minus f of x over x plus delta x minus x is going to give you nothing but f dash x. But the same thing here goes back to like velocity. So if we have velocity, the rate of change in position, we are calling it instantaneous velocity. Now in component wise, you can write here v is equal to dx over dt x hat, dy over dt y hat plus dz over dt z hat in 3D system. Now similar thing happens with acceleration, a is equal to dv over dt. Okay, so you can write here like a is equal to dvx over dt plus dvy over dt, so x hat y hat, and dvz over dt z hat. So in some sense, now I am not going to write here every time that dx by dt, dy by dt. So that's why we have introduced this vector, that maybe we are working in 1 dimension, 2 dimension, 3 dimension, we don't worry about. We can simply write dv over dt, this vector form, or I can write v as dr over dt. So now d by dt and d by dt, it will give you d2r over dt square. Now from now on, we are going to write like velocity is dr over dt. Now in physics, we are writing that if any quantity which is having the derivation with respect to time, we are simply noting it r dot. Okay, now r dot vector is nothing but this one, that's the right, and similarly a vector is nothing but dv by dt, which we are going to write at v dot. Okay, or simply say v dot, because you understand that either you work in 1 dimension, 2 dimension, 3 dimension. If you are working with 1 dimension, this v is r dot and a is v dot. Okay, or a we can write in terms of position is a r double dot. Now this definition is true in 1 dimension, 2 dimension and 3 dimension. So this is the way we actually work with interesting thing like position, velocity, acceleration and so on. So this is the way they have already shown you that how you can actually write these things in several dimensions. And there is a very interesting question like dr by dt, and they have some following form of position, like any vector is having position of this one, find out this velocity and find out this thing. So now for this instantaneous thing, you don't have to worry about that what is your x1 y1 or what is your x2 y2. Simply you just have to differentiate, and I understand that you know following things, that how to do differentiation. So for this video it is enough, and I think it is quite long, so but it is a very interesting and very informative, so please watch till the end. And if you have any friend, please share this video with them also. So this is Saddam signing out. See you later in my next video.